All right, for today, I need to teach you how to find the inverse of an equation. All right, and this Friday, it is not a formative, just to clarify. This Friday, it will be the actual test this Friday. All right, I'm going to skip through some slides on some little game kind of stuff, and this is old assignment stuff. For me, you probably don't even have that one. You probably have this one. Everybody find this one. This is a review question about the domain. And do you remember me setting up these equations for you and saying that's all I needed you to do on the homework was to set up the equations? All right, I'd like to do one from start to finish now with you to make sure you understand how to do that kind. And then what we do today, the new stuff, the inverses, that's the last new thing. And we'll spend another day on that new thing tomorrow. Get a little more advanced on the new thing. And then Thursday and Friday are basically reviews. Or sorry, Wednesday, Thursday are basically reviews. Part of Thursday will be the top 20. And then Friday test. So, all right, so this, if you recall, notice how this little g is the inside function. You always start with that. And then this says g of x. I just said g in the formula just to make your life a little simpler. But do you get it's not a domain? It is the function in d of f, which is the other. Notice it's really based on the two parent domains. G and f are the two parents. But it's a little more complicated because of this part right here. If it wasn't for this, it would just be the two parent domains overlapping. But it's that little part of the formula g of x in that adds some complication. All right, so here's a typical question. Here's a function and its domain. Notice right underneath it, it says its domain. It just tells you. Normally this would be all reals. Nothing would crash that. But they're telling you this is the domain given. X must be less than 4. And over here we have your G domain. And that one is not the normal domain for that. The normal domain for that function, here's a parabola that's been shifted down 5, would look kind of like that. Normally x could be from -5 to infinity. The domain for that parabola would normally be all reals. But again, they have artificially restricted the domain. You're in a hardcore class here. What I'm saying, a lot of people would be going right over their head, but I'm hoping you're getting that they're saying that even though normally you domain's anything, because that can't crash, then if it's saying that we want to say it has to be bigger than 1. We're like making this artificial saying that we only want it to work when x is bigger than 1. Okay, so there's my domains. They're given. Now how do I do this thing? The domain of G, that's just right here. It's that. And I'm going to write it, but I'm also going to put a number line and make it with a number line. Because to me, I see it better when I see it like that. It may be different, and you don't have to use number lines, but I think they're a good idea. Okay, stay caught up with me. Some of you aren't writing. And wake up. Then G of x in D of f. This is important that you not just watch me. You've got to do this with me. This has to go into that. Well, what is G of x? Well, that's not that hard. It's listed right there. X squared minus 5 needs to go into D of f. Where's D of f? I'll circle it in green. That's a bad idea. Blue. There we go. There's D of f. How do I put this into that? Well, where can it go? In the x. So therefore, it's x squared minus 5 less than 4. You get what just happened there? I just put this into there. And now, isn't that an equation I could solve? Add 5 to both sides. X squared is less than 5 plus 4 is 9. And now here's a classic mistake. People just go, oh, so you're saying x is less than 3. No. This is important. When you square root a variable, I warned you, this is going to come up like 35 times. That gives you absolute value of x. is less than, and that 9, that is not 3 and negative 3. I need to get this across to you because this is going to come up on your test. Again, everybody grab your calculator, your graphing calculator. If you don't have it with you, you're going to have to look on with a friend. Grab your graphing calculator right now. Okay, so I pulled up my graphing calculator, and I'd like you to see, if you go into the y equals mode, see if you can graph the square root of 9, because that's one of the things we had to do, is the square root of 9, right? Graph the square root of 9, and hopefully you can trust your calculator. All right, so I'm going to say square root of, and if you haven't seen it yet, I'm going to make it the key red. It's right above the x squared key, is right there. Square root of 9, enter. Now let's graph that. Does it say the square root of 9 is 3 and negative 3? No, it's just 3. I'm re-educating you right now because I know some of your teachers told you that you could say it's plus and minus 3. It's not. And it's important because we're going to keep, we keep coming up with this, and it's going to keep happening on your tests and stuff too. All right, so I'm going to go back to y equals, and now the square root of 9 is just 3, right? How about the square root of x squared? Let's find that one. Everybody type in, you can actually leave the square root there and just right here type x, which it's that key that's red right now on the screen. That's x. And then I got to square it. I would just hit the squared button. You can say caret 2, you know, like the little, this guy. You can use that key if you want to say to the power of 2, but I just use the squared key that's red. And now, take a wild guess what's going to happen when I hit graph on that thing. Would you please look on at the kid next to you and see this for yourself on that calculator? Is that an absolute value? It is. I'm not making this stuff up. Okay? So that means when you're solving this, that you have to know that this is the absolute value of x. And then I hope you know how to solve those. That's one of those top 20 things. I've got a problem kind of like this on the top 20 where you end up with an absolute value because you square root a variable. You split it into two things. And here's the easiest way to do this. You just say the exact same thing as what you see. X is less than 3. And then you make another equation that's a lot like that, except it's the opposite. And when you have the opposite, do you get that you need the opposite sign? So not x is less than negative 3. X is greater than negative 3. So what happened there is we had x squared is less than 9, and I showed you how to solve it, and it is not 3 and negative 3. Yeah, there's a 3 and there's a negative 3 involved, but it's not because the square root of 9 is 3 and negative 3. I showed you on the calculator. Square root of 9 is just 3. All right, now, down here, x is less than 3, x is greater than negative 3. Again, I think better when I see that on a number line, so I'm going to make a number line for that. Here's negative 3. Here's 3. It's got to be less than this and more than that. Notice it can't be 3 or negative 3. It's got to be an inequality. It's less than or greater than that. And now I'm going to overlap that because that's what this right here means is intersect. I'm going to overlap that with this. Now where should I put the 1? Well, that's right in between the two, right? So I'm going to go like that. And now where do those overlap? Only one place. They only overlap at bigger than 3. You get how it doesn't overlap over here? This is an empty line that extends this way. They aren't both over here. That's not overlapping. Yes? Oh, did I have this backwards? Crap. X is less. Yes, I screwed up my black graph. I'm going to fix that. Sorry. Right there, I screwed up. Negative 3, positive 3. I was good so far, but I assumed that it would be on the outside. Sorry. X is less than 3 means this way. X is bigger than negative 3 means that way. Thank you. And there had to be more than one person that was shaking their head like going, what's going on? If that ever happens, just raise your hand and ask right away. It'll keep us from going too far with me making a mistake, okay? Because you might not be wrong. You might be right, and I'm screwing up. Okay, sorry. Now I'm going to bring this down. And there's only still one place where they overlap. And that's a different place now. It's right in here. Would you please write your final answer for that in interval notation? Because as much as number lines are helpful, the answers are usually requested in interval notation. That means parentheses and brackets and stuff. And hint, there's a bracket involved if you're doing it right. Make your brightness a little bit higher. Or are you almost out of battery? Because I can't see it. And you could be hiding, I don't know what, underneath there. So, all right. Did you say from 1 bracket to 3 parentheses? Raise your hand if that's what you had. Okay, good. Now you saw me do that one. Now I want you to do one all by yourself from beginning to end. And this time, I'm not going to have the formula up there like that. Okay, I'm just going to give you your 2 equations. You'll have to figure out the domains. Remember that the formula started with the inside one. And then it's that same function. You know, this was the g, and now this is still the same function in the other domain. So just the first thing I want you to do is just this. If I do f, or let's go g of f of x, would you please just write what you think the right formula is for finding that domain? If you don't have the right formula, you won't possibly be able to get it. Write down the right formula for that problem. If you're having trouble starting, it starts on the inside. I'll pause for a second. Would you check with the kid next to you? Okay, I think most groups have already checked. You should have said the domain of the f function, you can call it a big D or a little d, I've seen both, intersected with the f function, and you could say f of x if you wanted to, in the other domain, domain of g. Raise your hand if you had that one right. Okay, good. That was the right way to do it. Okay, now what are these domains? Well, you know what? I'm going to save you time and just give you the functions and their domains, kind of like last time, instead of making you figure them out, because I want to get to the new stuff. Here's the f of x function. It's going to be x squared plus 7. And by the way, would that normally have any restrictions on its domain? Is there any way to crash it, in other words? No, you can't crash that thing. And so therefore, it's got domain of all reals. But I'm going to say that its domain for f is that x needs to be bigger than 3. Now I'm going to give you the g function. G of x is going to be 1 over x. Now, would you agree that that does have a restriction that it can't be whatever? But I'm going to say it's got a different restriction. I know x can't be 0, but I'm going to say the domain of g is that not only can't x be 0, x has to be bigger than 1. Now, I'd like you to follow the formula like I just did and see what the domain of g of f of x is. I'll pause for a second. Let me give this one a shot. Yes, sir. Well, first of all, the normal domain of g would be that x has to be not 0, which actually would mean a lot of things. Why isn't it that? Because just like on this one, I'm making up an artificial domain. I'm just saying it has to be this. And they do that in math sometimes. They won't just say the natural domain of this would be this. You artificially restrict it to be whatever you want. I have artificially chosen that it must be bigger than 1, even though normally negative numbers work. All right, give that one a shot. It's a really important review from yesterday. I would say this will be the hardest question on the test. The stuff I'm about to do with you isn't as hard. Okay, so first off, I hope D of F was easy for you because it was given. It's right there, it's right there. And so it's just x is greater than 3. I like to make a number line. Are we good so far? Okay, good. Then that intersects with F. Well, that's not hard to find. That's this guy in the domain of G, which is got to go in there. So you should have said x squared plus 7 in that greater than 1 thing. So now I'm going to have x squared is greater than, ooh, this is where the problem comes up, negative 6. Tell me when x squared will be bigger than negative 6. Just solve that. What is x squared is bigger than negative 6? Is that ever true? Can you square something and have it be bigger than a negative? So like take 5 and square it. Is that bigger than a negative? Yeah. Okay, so it's not a question of it's never true. Is it a question of it's always true? Okay, so then if that's always going to be true, no matter what you put in, that's always going to be true. Then what's the domain for something that's always true? Remember, what does domain mean? Domain means what can I put in this function? What can you put in this function? Anything. Everything. All reals. I get that's a weird thing, but you got to be able to handle that. The domain means what can I put in this function? Now, what if it had been the other way around? What if it had been x squared has to be less than negative 6? Is there any way for something squared to ever be less than a negative, as in a more negative, as in a negative number? No, there's no way for that. And so then the answer would have been, there is no domain, as in nothing could ever work if this had been a less than sign. But it wasn't. It was a greater than. So again, I know some of you were trying to like solve it and like take square roots and like, but I get you'd have a square root of a negative. Anytime you get a square root of a negative, you should start saying, something's different on this one. So what's different about it? You just have to ask yourself, what does domain mean? It means what works in this. And what works in that equation? Everything. All reals. So now where do they overlap? This one and this one overlap at from 3 to infinity. X, or I could put this. Oh wait, parenthesis. 3 to infinity. Final answer. Did anybody actually have that? Okay, I know some of you got stumped on the, wait a minute, I'm squaring a negative, or square rooting a negative. I can't do that. All right. If this had been more normal one, what if this hadn't come out negative? What if this had come out to like 8? Then you'd take the square root of 8, and you'd had the same idea where it would be like, okay, here's positive, or no, here's negative square root of 8, here's positive square root of 8, and it would have been in between them, like that. Or they can sometimes come out the way I did it by accident the first time, where it's like this. All right, so I want to stop there. I will do more review with you. The test on this isn't until Friday, okay? But I need to get the new stuff in. So let's talk about the new stuff. The new stuff is about inverses. So I don't know if you know anything about inverses. Do you know? Go to this slide, please. Do you know anything about inverses? Yes. Yes. Do you? Okay. I don't know if you know anything about inverses, but I'm going to tell you, how about this? Just, how about instead of inverse of a function, what's the inverse of a number? So like say I say 7. What's the inverse? Negative 7. Not 1 over. That would be not the inverse. What would 1 over be? Reciprocal. Okay. So they're not reciprocal functions. These are inverses. Okay, so if I said 7, you'd say negative 7. What if I said inverse of multiplying by 2? What do you think that would be? dividing by 2. All right. So inverses also have this strange property that if you take an inverse and you reflect it across the line y equals x, that's the equation y equals x, right? If I reflect it across that line, then it's an inverse. So for instance, let's say I have a parabola. My parabola looks like this. I have to reflect it across that line. Now that is weird. Usually you're used to reflecting things like this. That's reflected across the x-axis. But you're not used to reflecting things that way. Hint. It's the parabola goes that way. It's a sideways parabola. Well, let's look at this situation. This one's y equals x squared, a normal parabola. Take a wild guess what the blue one is. Has anybody memorized the sideways parabola equation? You can't just like throw a negative into the other one. It doesn't work. You got to do this inverse thing. Want to take a shot at it? Nope. I get what you're saying. In fact, that's a good way to think of it, as a square root this way and a flipped square root that way. That's really cool, but that's not the equation for it. The base equation for what you just said, though, is y squared equals x. That's a parabola that goes sideways. Grab your, wait a minute, I can't have you graph that on your calculator. You know why? Because your calculator needs it as a y equals, right? You can't have it as a y squared equals. So you couldn't graph that on that, but you could graph it on Desmos. You don't need to right now, but if you've never seen a sideways parabola, Desmos is a graphing app that should be on your calculator or on your iPad, and it's a really good one, like very high quality graphing app. Works better than your calculator for sure. And yeah, can you hold that up? She's got a graphed a sideways parabola, and that was Desmos? Okay. All right. Okay, so what can we learn from that? Well, inverses are, it's really, really simple. Can you see what happened between the blue one and the green one? X and, yes? Yes, or another way to think of it is, you flipped the variables. The x became y, and the y became x. Let me give you a point that would be on this one and a point that would be on that one. Would you agree that if it's truly the x squared function, then when I put in 2, that up here there should have been 2 comma 4? Then take a wild guess what's on that blue one. X and y switched, so 4 comma 2 will be on this one. So here's the theme that you need to get. On inverses, the x stuff becomes y, and the y stuff becomes x. If you have the point 6 comma 8, it's going to become the point 8 comma 6. Also, since the x stuff becomes y stuff, the domain of this one becomes the range of the other one, because x stuff becomes y stuff. There, I've just told you everything in brief outline that you have to know about inverses, but now I need to flesh it out a lot more. But inverses are a flip across the line y equals x, and it's where x becomes y and y becomes x. All right, so here's like the simplest inverse equation ever. Y equals x plus 2. Then take a guess what you think the equation is if it's the inverse. X equals y plus 2. What just happened? I switched x and y. Now, could I solve that for y by subtracting 2 and get y alone? Y is equal to x minus 2. The green one and the blue one, they're different. Here we had plus 2. What's the inverse of that? Minus 2. But it's important that you not just think oh, I'm going to change it to y equals x minus 2 because I'm just going to subtract 2. Like, don't do that. That's not what happens with inverses. What happens with inverses is that x and y switch places. So the y becomes x, the x becomes y. There. Now I've got my equation. That's all there is to it. It's just usually I have to solve it. So yes, it's this simple. If you just had y equals x squared plus 3x minus 5, and you wanted its inverse, you just go x equals y squared plus 3y minus 5. There, that's the inverse. But we don't let you do that. We make you solve it for y, which makes it much more complicated. But that's all it is. X and y switch places. That's it. So if I named a point on this one, any point on that one, so I'll put in the simplest one where x equals 0. 0, comma, what would it be? Come on, stick 0 in this function. You got to participate more. I'm asking you to do something super simple. If I stick a 0 in that, what do you get? Negative 5. So 0, comma, negative 5 is a point that goes in that function. Then name a point that's got to go in this function. Negative 5, comma, 0. Get what I'm saying? The x and the y switch places. That's the theme you should be catching from this. All right? And let's say the domain of this, and I'm making this up now. Okay, let's say I said the domain of this was x is bigger than 5. Do you get that would become the range of this? Because x and y switch places. So if the domain of the top one becomes the range of the bottom one. How about this? This one is actually accurate. The range of this one is, well, actually, dang it, I need to know what its vertex was. So I'm going to have to make up the range again because I don't know what this guy's vertex is. So if I give you the range of this one and I said x has to be greater than 3, greater than or equal to 3, that becomes the domain of this one. Because the stuff that was the x, sorry, the range was y is bigger than 3, would become the domain of the other function. All right. So I'm hoping you're getting this inverse thing is that x and y switch places. That's the main thing you got to get. So let's actually get to a few where we can actually do that. Let's find right here in our homework. You ready? Number 2. Now, the first thing they do is throw in f of x. Wait a minute, you were just kept using y. Well, can't you just change f of x to y? Yes, you absolutely can. So if that's really y equals 42 minus x, then what's the equation for its inverse? X equals 42 minus y. And then do you remember me saying that you had to solve for y? It's important. You do. So now I have to solve for y. So go ahead and do that. It's not that hard. Solve for y. Get y alone, including the negative that's on the front of it. I am doing your homework here because this is the first couple questions. The ones that are circled are the ones we're going to do. If all it was switch x and y, you got to admit that is incredibly easy. Of course it's more than that, but you switch x and y, but then you got to solve for y. Now I have negative y is equal to x minus 42. Now I'm going to multiply everything by negative 1. Y equals negative x plus 42. There we go. That's the inverse. Now, it says to check your answers algebraically and graphically. I am not going to require you to do this, but do you get that if I graphed this and I graphed this, that they would be a reflection over the line, what again? What was that line they reflect over? Yeah, y equals x. Here's the line y equals x. If I graph the one equation and I graph the other equation, they will be a reflection over that line. So if the one graph looks kind of like this, the other graph would look kind of like that. It will be a reflection across that line. That's how you could tell graphically that you were doing it right. But that would add a lot of time to your homework. I'm not requiring that. And on the test, you're going to have to show it algebraically. So basically, flip-flop x and y, and then solve for y. All right, let's go to this one. Currently, it says y equals, because I changed it to a y. And then I'm going to switch it to x equals 1 minus 4 plus 3y over 5. Now, do you know how to fix it when there's a fraction involved? We've been pounding on that since the beginning of the year. It's in the top 20, clearing fractions. You multiply everything by what? A little louder, please. Come on, what do you multiply by? Thank you. I multiply everything by 5. Because if I had had 1 plus 3 equals 4, I times them all by 5 to keep it working. 5 plus 15 equals 20. Okay, that's why I multiply everything by 5. Okay, now that I did that, this 5 cancels that 5. And it's 5x equals 5 minus 5x equals 5 minus 4 plus 3y. And I know you can solve that for y. And the 5 minus the 4 will make 1. Subtract that from both sides. And you get y alone, and you got it. This one. X equals 3 square root of y minus 1 minus 4. You're trying to get y alone. You start by adding 4. The second thing you do is divide by 3. You got to get the clump here alone before you can square both sides. You will eventually square both sides, but you start by adding 4. The next thing you do is divide by 3. Then you square both sides. All right, moving on. All the ones that are circled here are the ones I'm assigning. Just the circled ones. Now, getting to the back here, this gets really tricky, but not impossible. I'm going to say, why don't you just skip these two, and I think you should try number 24 because it's got extra variables in it. That's like the ACT questions that are the hardest. Instead of just having X's and Y's in it, they throw in an extra thing like a B and a D. And it gets a little weird because you got to drag that B and D around with you everywhere. Actually, there's a C and a B and a D and an A. But that is a typical tough ACT question. So challenge yourself on number 24. You just switch X and Y around. And hint, the first thing you got to do is clear the fraction. That's why it's a top 20 skill. Because you do it a lot. All right. And that gets us to the end. The weekly quiz thing, ignore that. We don't need that. Got enough on your plate for today. Okay. So big picture again. What's happening on Thursday? Top 20. What's happening on Friday? Test. And if this video is seen in some different year, that's approximately, well, today's a Monday, so that's like 1, 2, 3, 4 days from now will be the, 3 days from now will be the top 20 test, and 4 days from now will be the test. Stuff. Okay, that's your intro to inverses. And we did a lot of stuff from Fridays, too, where we had those complicated domains that are F in G or G in F, that kind of stuff. I know, today's pretty intense. But honestly, this test isn't that hard. We have so much time to review that you're going to get really good at this by Friday. But you got to do your part, which is get your homework done tonight. That's all I got for you for today.